Okay, what else should I say? I should say something about choices of the axes. So we've been doing left endpoints, right endpoints. You could do, say, midpoints. What we want is to have a kind of a stable definition. We want it to not matter. Okay, we want it to not matter if we start with left endpoints or right endpoints or midpoints. Okay, it's going to be trouble. It's not going to be a coherent definition if it matters how we start. Okay, so this lim Rn, better be the same thing as lim Ln, right? It better be the same thing, or we have a problem with something's going wrong. Okay, so don't worry too much about that. It's just a technical but important detail. What else I want to say? Okay, A and B have special names. Let's write that as a second note. A and B are called the limits of integration. So let's talk more about this first note here. I want you to imagine, if you will, a function that is not entirely positive. Let's see, we have A here, and we have B here, and the function does something like this. And we put some dotted lines here too. So we'll call this function f. Now, this is an area. We'll say that's A1. And this is also an area. We'll say A2. And we will make the convention that areas are positive, right? These are, say, physical quantities. A1 is bigger than 0. A2 is bigger than 0. So that's an important starting point here. Now, when I do the integral from A to B, what's happening is you're kind of, you're filling this, you're doing rectangles here. You're also doing rectangles here. Now, if you think about these rectangles down here, I guess you'd say, let's say this is x17, f of x17 is going to be negative, okay? Exclamation point. So what that means is that when you do this sum, delta x, f of x1 plus dot 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 plus f of x n, let's say, sum some terms are negative. Because you're going to have some negative terms here. So this explains why um, the definite integral is not always the same as area, because the negative terms are going to introduce some cancellations, okay? So in fact, if I work out this integral, in this case, it's going to be a1 and also a2, but it'll actually be subtraction there. Okay, so that's perhaps the main takeaway here for this example. Okay, if you have some part of the curve that's under the x-axis, then the indefinite integral will end up being this. It will not be area in any sense. It's going to be some subtraction of areas.